Everyone, welcome. Good morning. People are getting settled here. We have to get started promptly, so welcome to the session. This is Scripting DX. Just a show of hands, who went to the concert last night? Okay, wow.
Here in the morning.
Wow, you guys are brave. All right, so this is Scripting DX. We're talking about using build tools to automate your development today.
I'm Brian Leboff. I'm a senior consultant at Aperio, mostly in development, tech lead type roles, but focused a lot recently on DevOps and release management and that type of thing. And I'm also the SFDX product champion at Aperio, so anytime somebody from Aperio has a question, how to get started, how to utilize it, I'm their go-to resource for that.
And you're also a taco, right?
And I am a taco. Yes.
And I'm Ray Daler. I'm a principal consultant at Aperio also, and I mostly deal with technical architecture or tech lead roles, and I'm a consumer of DevOps processes, so that's why we're here. Our Twitter's on the bottom. Feel free to tweet at us during or after, and we'll have conversation continuing as well. So what are build tools? We're going to talk through the agenda. What are build tools as a beginning? We're going to talk about why we should use the build tools with our processes. And then we're going to give an intro on the Salesforce CLI and how to use that within your build process. And also showcase it with the continuous integration tool. Then we'll spend quite a bit of time on the demo. Most of our time will be demo today. And then we'll wrap it up with resources slide and questions and answers at the end. We should have some time if we have some questions come up. So first and foremost, what are build tools? So build tools are programming language specific tools to automate some tasks. Some examples you see here are compiling code, generating binaries, which are distributable versions of your code, doing things like minifying, uglifying, or otherwise obfuscating front-end JavaScript code. Our build tool can help us with that. Doing static code analysis and lint checking, doing security checks, conforming to OWASP standards or some other standard that you need to conform to. A build tool can ensure that you do that. And then probably most commonly, you want to confirm that use a validation that your build doesn't break. So the tools allow us to run these common tasks easily and consistently, and we'll talk about that in a minute. Some of the common apps you use or build tools that you use are seen here on the right. We have Apache Ant, which is the Force.com migration tool, is based on that. And then some other ones, Grunt, Gradle, and Gulp. We're going to be showcasing Gulp today, but you can use any one of them. It's pretty agnostic. And most importantly, these tools are essential for continuous integration, and we're going to try and drive that home today, that anything you do with continuous integration, you have to be able to do as a developer, and build tools enable that. So what is this all based on? Three main things. First thing is source-driven development. Some of this is not new if you've been following Salesforce DX feature set in the past year or so. But source-driven development is in contrast to sort of traditional Salesforce development where the org is the master, the org is the source of truth. So now we try and have the source be in the repository. So source-driven development enables that. So version control system or source control is an absolute prerequisite for this. It is what enables all of this to be possible. And Git is most common these days. There's some cloud-based Git providers like GitHub, Bitbucket, GitLab. All of them integrate with continuous integration servers. So it's important you use that to get started here. And like I said, the important thing is the repository is the source of truth. So next, that's source-driven development. Next, we talk about Salesforce DX feature set. Again, this is not new. We're just kind of touching on it lightly here on what it does. But the real key thing there is we introduce artifact-based projects. So traditionally, again, with the repository, you would have your entire source in a project. That's one way to do it, probably the most common way. And so with artifacts, you want to ensure that your group of common metadata or things about your project are separated. It's not just one project within your org. So Each one could be an artifact, and again, it's just a group of common features or customizations, so it's split up. And Salesforce DX also includes information about your org. You can do this with the Salesforce DX feature set, and Brian's going to touch on that a little bit later about everything that's included here, and we'll talk about things like org shapes and for your Scratch orgs. So Salesforce DX enables that with the packaging as well. And then finally, we have the Salesforce CLI. So this is a scriptable and extensible way to use the Salesforce DX feature set, and again, used by the CI tool, continuous integration tool. So why should we use build tools? So first and foremost, we have consistency. We want to ensure in our build tools that our Scratch org that we're validating against is the same as our other developments. So we want to have consistent configurations for both data and metadata. And again, Brian's going to show what this looks like in the demo a little bit later, but that's very important. We need to ensure this is the case. Otherwise, one task could fail for one person and succeed for the CI tool. And also, continuous integration is it's very enabled by the build tools, right? So we want to ensure that developers can use the same commands as the CI server, and build tool, like I said, enables that. So second, why else we should use build tools? Did I already talk about that one? Okay, no.
We're going on. All right.
Oh, sorry. So just to wrap that up, my mistake.
Cool.
So yeah, like the picture shows, we have all the ingredients, and we could do it all without build tools. We could issue all the commands in the same order, but it really just enables us to. It's like a recipe. You follow the recipe, you put it together in the right order, and the build tools can help us with that. And this all makes sense in a minute when you see this in action. But we want to ensure code quality is another reason we should use it. So we can enforce standards like linting and naming conventions. We mentioned most of these already. Naming conventions would be, if you want a camel case, you can have your build tool insist upon that and ensure it. And then test coverage is something we haven't mentioned yet. So often we need to ensure that we have over our 75% or maybe higher in some cases. So we can run tests as part of our deployments, our validation. And as you can see on the right, some orgs have a tab versus space requirement or preference, and so just another thing we can validate and confirm.
Real hot debate.
Yeah, real hot. So efficiency also, another reason we should use build tools. It's a lot quicker to get up and going with one command of, let's say, 10 characters. So what we'll show you today is like a gulp build command rather than a SFDX force org create, right? Plus some other things. You have to auth before that. You have to push. So if we have it all consistent within one script, with one command on the script, then it saves us some time, and we don't get the steps wrong. So yeah, again, efficiency, it gives us efficiency gains if we use these build tools. Are we okay down there?
Yep.
Okay. Yeah, so let's move on here. So let's talk integrating the Salesforce CLI.
Yeah, so we know we have the Salesforce CLI tool, but it's not enough just to hand off the Salesforce CLI tool to your developers and say, get off and running. You kind of want to enforce some consistent processes, and the build tools really help with that. So the first thing that the Salesforce CLI offers us is some configurations, right? So with Salesforce DX, they've introduced the concept of Scratch orgs, and these are kind of transient environments, and they help us do software development for Salesforce like we would do normally in a traditional software development project, where developers have their own local kind of builds of their changes and change sets. So the Scratch org is kind of each developer's local build environment. It's just the Salesforce CLI, to create those Scratch orgs, uses the Scratch org configuration files. So those are the shape of your Scratch org, so it enables things like different features. So if you have chatter enabled or different licenses, different editions, so enterprise edition or developer edition, whatever the shape of your production org is, you can create a scratch org with those types of features enabled, and those are all contained in configuration files that you should be maintaining in your repositories and sharing with your developers, so when they go to create their new orgs, they're creating the same orgs that all the other developers are creating. And there's a consistency there. And then also there's the test data sets, right? So the CLI tool lets you export data from an org. So with the force data tree export, I think is the command. And that'll basically do a JSON data pull of some test data sets, and those also will live in your repository, be shared among your developers, so when you're pulling data and loading data, everybody's using the same data. And that's generally an issue, I think, today in Salesforce development, where you spin up a new sandbox, doesn't have any data in it, you have to repopulate the data. There's not an easy standard way to do that until Salesforce DX, so that helps a lot with that. So those configurations kind of enable our build tool processes. Moving on. So how do we integrate this CLI and all the benefits that we get from it into our build scripts? So what we've done is actually create a node package called SFDX node. You can pull it down off NPM if you'd like. And what this does is, so the Salesforce CLI tool, it's a Heroku, it's like a fork of the Heroku CLI tool. I guess is probably the best way to put it. But really it's, yeah, hold on. Sorry, I missed my note. All right, yeah, so it's kind of a fork of the Heroku CLI tool, but it runs on the command line, but we want to run it within our build script. So we have a couple different options to do that. You could execute the shell commands like from node, but there can be platform inconsistencies there. You can have, like, if you're on Windows or Mac, you can run into some issues executing shell from node. So what we did was we actually wrapped the command line tool in this node package that lets us just directly call those commands from within node. So the way it works is basically you just require the SFDX node package. So if you look at the top line, that's how we would create a scratch org within the CLI tool. That first part, the force, that's like the namespace for the plugin. Second part, that's the topic org. And then the last one is the command create. So we just do SFDX, the topic, and then the command, and we can pass in any flags that the command line accepts, and it'll just run that node method, basically. And then, as you can see where it says the command, and that's camel cased, if there's nested commands, those will be camel cased as well. So now let's see this all in action. Let's see what this is actually buying us. Give me a sec as I switch over here. Cool. So I'm a brand new developer on some project. The Dreamhouse project is the one we're using for this. And I get my first task, right? So I get my first task, and I get a big manual of all of our processes and all of our standards, naming conventions, and things like that. So the first thing I do is I go down and I clone my repository. I already did that, save some time.
Can you guys see this? Is this clear to everybody in the back?
Yeah, I can make it bigger too. So I'm in my repo, and let's open up VS Code, and let's take a look at the README, because now I need to get started. So it says to get started, all I have to do is npm install. So that's the first thing I need to do. So we're going to go back, npm install. So this is going to install that package. It'll install that, the hook into the Salesforce CLI. And the nice thing about it is the developer doesn't actually have to go out and install the Salesforce CLI for this. They can just, once they do npm install, they have everything they need. So now that that's done, we'll go back to the README and check out what I need to do. So there's 3 commands I got to run here, right? I have gulp auth, gulp init, and gulp watch. So gulp is our build tool, and then these are the tasks within that build tool. So if I run gulp auth, so this is going to do the dev hub authorization for me. So generally you'd be logging into your production instance. I have my little dev hub trial here. And now that I'm logged in, that part's done. I might not have picked it up quick enough. We're going to have to run that again.
Live demo.
I can't believe I closed out of that window. Sorry. Yeah, so that would generally authorize my dev hub org. Then the next command I have to run is gulp init. So let's see if this is going to work. Cool. Yeah, so it did work. And so what gulp init is going to do, so if we take a look at our gulp file here, this is what defines all of our tasks that we're running here. And first one up here we have is gulp init, and it has a number of dependent tasks. So we have create, init push, init assign, and init import. So it's going to run all those tasks just by typing gulp init. So it's going to create my scratch org first, then it's going to push up my source, then it's going to assign the Dreamhouse permission set, import the data, and then finally it opens the scratch org. So this is the new scratch org, created, metadata pushed, data imported, permissions assigned, and all with one command.
Pretty cool.
So I had in, every time we practice this, I say, and I pause for applause. So I'm glad I got applause. And you can see that if I go into the object manager, we have all the Dreamhouse stuff in there. So my first task as a developer, I need to add a field, right? And I missed one command, the last command, so I did init and that worked. But now we're going to do gulp watch. So what gulp watch does is it kind of watches your local directory for any file changes. So if there's any changes to the, so you give it some parameters here. So I'm saying if there's any changes to our fields, run the check fields command. And that's going to give me some information about our naming conventions and standards. And then if any changes are made to our classes or triggers, it's going to run the push command and push those automatically up to Salesforce for us. So my first task is to add a field to the property object, just a checkbox.
So the idea is, excuse me, this watch is running all the time, right?
Yes.
It's running in the background while you're developing.
So I go in, checkbox.
The Gulp script you're showing, is that something you wrote, or that?
Yes. No, so basically, yeah, that's actually a good question. So we write all the tasks for the Gulp script, right? So we use, we create these tasks to call those Salesforce CLI commands, just in the order that we would want both our developers to do it and the CI tool to do it eventually. So the command that the developers are running, that gulp init, that's the same exact thing that CI is going to run when it needs to run its tests and do everything. So it just ensures that consistency between what the developer's doing and creating and how we're eventually testing that and deploying it.
Yeah, and we'll have this shared. You'll see it at the end of the presentation.
Yes,
a link
this
to
is
it.
all up on GitHub. Cool. So I'm adding my new checkbox. No permissions. Yes to the layout. When I go back here, we can see that watch command. One of the other things it was actually doing is checking Salesforce periodically for any changes. And you can see it pulled down my checkbox. But I have some issues here, right? So spit out a couple warnings. My field is missing a description, which we are enforcing on all our fields. And the label doesn't match the API name, which can be very annoying sometimes. So as the developer, I see that, and I can go back in and make my updates. My checkbox. Just going to take off the my. I'm going to give it a description. And if I go back to my watch command, we'll see next time it comes back, it pulls the field in, and there's no warnings. Thank you, thank you. So now I'm also going to update one of my classes to return that checkbox when you try to find by ID. I don't know why we're using that checkbox, but we are. And so once I save this, that gulp watch command, it's going to pick that up, that change was made, and push it up automatically for me. So it really just takes a lot out of the hands of the developers and automates things for them, makes their lives a lot easier and more efficient that way. So now I'm done, right? So now I've made my changes, and I want to get these deployed over into my testing environment. So QA can run their tests, make sure the checkbox is there, and people can use it. So I'm going to create a new branch here, new feature branch. I'm going to add the changes that I made. Yeah. Commit them. And then push up to
Origin. Yeah.
Origin, yep. Been working in a lot of repos. Womp womp. Oh, I already had a branch up there called new checkbox. That's what I get for practicing. Mm-hmm. Cool. So now if I go up to my repository, I see other checkbox just got pushed. That was very quick. And I create my pull request to then get reviewed by my lead developer so they can merge in my new checkbox. Now I hand it off to my lead developer.
Right. So quick recap on what you saw. So the developer issued a series of commands, saw some validations were failing, some warnings were given, and addressed it. And now he's pushed it to his GitHub, his remote repository, for the continuous integration server to perform the same validations. And so that's what we're going to see here. We integrated with the Travis CI tool. It's free for open source projects, and there's a great Trailhead module on how to set it up with Salesforce DX. I encourage you to check it out. We have a link to it in the resources you'll see at the end. We made very few modifications to it, simply just to replace the Salesforce SFDX commands with our gulp commands. And you'll see our changes as well when you check out the source. What we can see here, as a lead developer, I would look at this. So there's two things happening. The first one is this push. The CI server is trying to build the push, and then it's trying to build the pull request. So from here, I'm in GitHub. If I click on details, this will load travisci.org. What did I just do?
Just click on it, yeah.
Okay. And so it's actually started, and it's been running for 50 seconds, we can see. So one key thing to the continuous integration server running is that it uses JWT auth to authenticate with your dev hub. And so there's a great tutorial on how to do that, again, with the Trailhead module. I won't go into too much detail on how it works, but we can see, if I could find the line, right here. It's actually decrypting our server key so that it can authenticate with our dev hub. First thing it does after that is install the Gulp CLI. Again, we used Gulp here, but there are, it's agnostic, so as long as you can install it, you can use it. And then he does an npm install. If you remember, that's what Brian did first. So again, issuing the same commands that Brian did. It does gulp init, which is dependent on auth, first and foremost. So you can see it does auth first, then it does create, it's creating a scratch org for us, and then it's doing the push. Everything that's in the Dreamhouse app is being pushed. You can see here if I keep scrolling, lots of stuff.
They had a lot of stuff this year.
Yeah, a lot of this is new for this year, yeah. So after that completes, you can see it took 28 seconds. It's going to assign the permission set and then import the data. This is all part of the Dreamhouse app, so it's not that we created this information. It's all available already. Finishes the import, and then it finishes the init, pops the stack. So after that, it's going to run the check fields command. That's what Brian was running with his watch indirectly. So it'll check for the fields API name matching the label and the descriptions present. You can see it passed. There's no warnings. So again, we're issuing the same commands the developer did. Rather, they're issuing the same commands we would, so they can preempt any issues. After that, it's going to run the gulp test. Brian did not run this, but again, we don't want the build to fail. We want to ensure all of our tests can still pass and we can eventually deploy to production. So we can see here's the output of that. Everything is passing. Here's a summary as well. We have our pass rate 100%. So the command succeeds, so the build will continue. And then it does a clean. So after it's validated the deployment with the tests, then it will delete the scratch org. So that's what the clean command does. So again, the CI tool is simply running all the commands the developer did. And once it passes, we can say the build passes. I did it again.
You gotta watch out for the top left corner.
Very fragile. OK, so if we go back here, refresh, all the checks have passed. So I'm confident at this point, relatively confident, I suppose, that we're OK to deploy this to our next environment for either quality assurance or user acceptance testing, so we can eventually deploy to production. But our CI tool, again, validated everything the developer did and is able to proceed. So I would merge it at this point. So that's it for what a tech lead or dev lead would do. And again, just confirming what the developer has done, all the commands they have done. Let me get back to this. There we go. So that concludes the demo on how to use this and how we would use this in real life scenario. Thank you. So in review of what we talked about today, our build scripts will create consistency, ensure our code quality. It's going to empower our developers, and it's very essential for continuous integration servers. So here's our resources slide. We'll pause it here and open for questions and answers. We have about 12 minutes, it looks like. If you have questions, please come to the mic. Otherwise, I'll do my best to repeat, and we'll stick around.
And we'll put the presentation in the chatter.
Presentations in chatter, and there's also a link to it. Oh, there's not a link to it. So you'll see it in chatter.
We don't have a link.
Yes.
So the biggest thing that we're running into as we're moving this direction is how do I find the other metadata types that are not Apex classes or field sets? We frequently find ourselves in this place of, okay, well, I figured out how to get the Apex class, I figured out how to get the object, but I also need a page layout, I need a permission set, I need all sorts of other things that we didn't necessarily know that we needed, mainly because we're approaching this more as your general fair developer versus Salesforce developers. What is a good strategy for figuring out all of those bits, and also how do I pull them out of Salesforce so that I can store them in a repo?
Yeah. So with the Salesforce CLI, one of the nice things is when you add a field, right, and you've made some changes to the layout and the profiles while adding that field, the CLI is kind of smart enough to know that those changes were made, and when you do the source pull, which was running automatically by just pulling Salesforce for us, but when you run that command, it's going to pick all that up and pull it down for you. So that's the case with the CLI tool, if you're using that, and scratch orgs, so that source pulling only works from scratch orgs, but yeah, the CLI tool kind of does all of that automatically for you. Like if you saw when I was doing the demo, I added that field, also added it to a layout. When it did the pull, it pulled that layout down as well. So it figures that out for you.
Right.
I have a question about if we have multiple packages, managed packages, and they're namespaced, how to develop, they're dependent on each other naturally. And how would we come up with a technique to simultaneously like work on all our packages at the same time without having to like deploy a managed package every time to propagate it out? Like, have you come up with a technique for a situation like that?
So can you explain the scenario a little? So what do you mean by working on?
We have like one master package, and then we have 4 other managed packages that actually depend on it.
Okay.
And it's a nightmare to try to update these or all the packages actually, because they're all namespaced. So I was hoping maybe you knew a technique to help with
Don't offhand.
I have to think about that one.
Yeah, for sure. So when you say you're trying to update multiple like you change a piece of metadata and you want to update it in multiple different managed packages, is that what you're saying?
Well, like the dependency package, if we make a change there, for it to, the other packages to reference it, we have to do a full build, which takes lots of time. And heaven forbid if we screw it up and we get locked with some meta that we don't want. So I was hoping maybe a Scratch org might be able to, I don't know, be able to handle namespaces somehow.
I have to get back to you on that.
Okay.
Yeah, well, I mean, maybe we could talk about it after the session a little bit more, but just, I mean, probably not something we can solve right now for you.
Okay.
What's the maturity model here if you're trying to integrate something like Jira or VSTS, so to make sure when you finish a task, it closes out, you get the burn down, the whole 9 yards? Where's that at?
Yeah, so that's just something you can build right into your script, right? So if you want some Jira tasks to get closed out after a merge, right? So you would build that into the build script, be some command like close task, and then CI would just have to call that command. So that's just something you would build right into your build scripts to kind of enable that automation for you.
Yeah, presumably if they have an API, you can use it from the build tool.
So currently we version control everything using the metadata API structure.
Yeah.
And even just code because like profiles have always been problematic.
Yes.
Do you have a strategy for like converting that version control to the new Salesforce DX structure? And also our profiles just managed better in Salesforce DX?
Yeah, so it's probably very implementation specific. So you can just take your big like repository right now and run the CLI tool has a convert command that'll convert it into that new format for you. See how far you get with that. Depending on the size and complexity, you might have to do a lot of thinking about breaking out different components into separate kind of apps, as Ray was saying, where it's like artifact based. So if you have some logical delineation between your different artifacts, then that would probably go a long way to getting to the point where you can be using Scratch orgs for your development.
Yeah, it's a process. It's probably not going to work just converting it. I mean, you do have to split it out, most likely. So if it's sufficiently large, let's say. And it is a process. I think it's still maturing in that front about how to do that, but it's only going to get better with time, I think.
Thank you.
Hi guys, thanks, this is awesome.
Great.
Any special considerations on branching strategy?
I think it's just a preference. So I'm a fan of the feature branches and that kind of Git flow.
So you don't have to do anything different, or there's...
So the CLI and the build scripts, that's all kind of, it's even like version control agnostic, right? If you wanted to use SVN, which I don't know if people still use, but you could, right? So it doesn't enforce any of how you're doing your source tracking. It's just, it kind of enables you to do that easier with Salesforce.
Yeah, check out the Travis docs. It talks about how to validate certain branch names differently, or if you want to do something then other than feature branches, or if you have some special requirements, check out the docs. There's plenty of information in there.
Awesome, thank you.
Yep.
All right, so this sounds amazing for pushing to QA. It's awesome. As far as going from QA to production, in terms of auditability and separation of responsibilities, are we still stuck with change sets, or is there a better way to kind of make sure that goes on up?
Sure. So we didn't really talk about the process of pushing to QA or anything. This is more automated testing before we get to QA.
Yep.
So the idea is once I merge it in the demo with the master, then it would kick off some other process to push it to QA or some other
Yeah, so to
target
get to a
environment.
sandbox, the source can't be in that Salesforce DX source format. It actually has to convert it over to the metadata format first. So you would have to just add some logic in the build script to say, when I do this merge, now convert this source over to metadata and deploy over to my QA environment. And then the nice thing about that is that package that you've now deployed over to QA, when you're going to production, you're just doing the same thing, right? There's no difference. It's just a different target environment.
Cool. Thank you.
Yeah, thanks.
Hi, my name is Abhinav. I'm a Salesforce developer and test automation engineer as well. So my question is particularly on the Gulp test that you were running. Were they unit tests?
Yeah, so those were Apex unit tests. The CLI tool lets you do all sorts of different type of testing, but that was just running the command, if you're familiar with the tool, force test run.
And a follow-up question to that. We have test automation scripts built in Ruby Selenium, which we have uploaded to GitHub. So how easy is to integrate those test automation scripts with the build tool?
It'd be very easy. I mean, so Selenium there's Node packages that let you run your Selenium scripts. So like anything you can really do in Node, you can add to your build scripts and automate.
I can use the Traverse CI. What is the name?
That I don't know specifically.
I'm sure you could. We can't speak authoritatively, but I'm sure you could.
Thank you so much.
Yeah, Travis is headless. So.
Hi. Our organization is pretty new to Salesforce, and we have a consultant company helping us, and the build that they're recommending right now is quite different from this. And I think this looks much more awesome. I'm just wondering if you could comment on how is the maturity of the whole DX thing?
So I think it's light years ahead of where it was even like a few months ago, right? So they're very rapidly.
So you're saying that that's definitely the way to go right away?
Yeah, I think if I'm starting a new project, especially Greenfield, I'm starting with DX.
Okay.
And
thanks.
Yeah.
One more question.
Hi, the questions on to go from org-based to source-based. Would you recommend, in our work, we have few applications, but how do we start separating those and putting into its own repository? Do you have any recommendation to that?
Yeah, I mean, that's an art. It takes a lot, and there's some blog posts that have been published about it, and to be honest, there's things in process that I'm working on that it just takes a long time. So I would say you just got to keep working at it, and be diligent about this is part of this project or this is part of this artifact, right? And separate it out like that.
Yeah, and I think having some processes around where your metadata is ending up, like which in which app, and how those dependencies are defined, and when things are cross-dependent, which I think is the biggest blocker, right? So you have a lot of integrated spaghetti type code for a lot of people. Yeah. Splitting those out and just having a lot of governance around that probably goes a long way.
It's certainly easier greenfield. I mean, that's a desired approach.
Okay, thank you.
Thanks for the awesome presentation.
I
missed one thing in the demo. When you did these declarative changes, adding a new field, what triggered the force pull that then made the watch script fire?
Yeah, so the force pull was actually, and I did skip over that line in the code, but it was just polling Salesforce and running the SFDX force source poll like every 10 seconds. I don't know if that's best practice, but it worked for the demo.
Okay. Thanks.
Yep. Okay, we're out of time here. Thanks everybody for coming. Appreciate you joining us.
Thank you, guys.